Bienvenue, rebonjour.
Well, good afternoon again. I decided I would change my presentation slightly because I realized that a lot of people in the room do not really know Wakanda. So I decided I would spend more time showing you basic things about Wakanda. Because I have the feeling that this morning you were shown the novelties, but it wasn't really well perceived because people did not know the product very well. So during the day, I was asked about volumetry, how Wakanda can manage a huge quantity of data. Here I built a database of 1 million records. 1 million employees are connected to 1,000 companies in a random manner between 10,000 in between 50 and 10,000, just to show you the queries, the sorting, and how we can build the interface with this. So the model is extremely simple. So I have employees, company. In Wakanda, an attribute can be a relation attribute. Here, for an employee, I want to have an employer, that is to say a company. And Wakanda will automatically manage the jointure, the foreign key, the primary key, and each employee can also have a manager, which means that this manager has a list of people, direct report, and the company has a list of employees that works for this company. It is a way of having a basic example in which you can process the volumetry. So there's about 1 million employees here and about 1,000 companies. So I'll start with building something simple. We're going to create a grid, and then we'll build different things. So this is the grid I do for the employees. And in the grid, I just have some of the attributes. So here we have 1,178,000 employees. I can scroll down the grid, handle the data. In fact, the server answers. This is a local network, but we also have good performances with an internet network. What happened there? Well, we're going to look at the details, how Wakanda works and how data is transmitted. We talked about open system based on Rust. Globally, the first time I have my grid appearing, I have a data source that I have created in my page, and it has the same name as my data class by default, but it's in like small print. This source says, okay, I'm going to get this data in this data class, regardless of the query that is done. I will have a collection of data at one point. It might be empty, but I will have a collection of data. This collection will be can be handled in the data source. It can be just one entity or a large number of entities. In this source, you can start with doing queries. And quite simple things. I take all the sources that are present in my page. For example, I have just one here. It's called employee. And then I do a query. The principle for Wakanda is that as soon as you modify a data source with a query, automatically this source wants all the ones that are subscribes that have a subscription to these changes. Here it is the grid. So the grid will be drawn when the source is modified. So here I modify the current collection. Here I have 1 million. I'm going to carry out a query here. Those whose name equals a given parameter, and I don't know, as a parameter I put DAC. DAC star being the joker. So it's got that in 1 million files. Well, it's actually got 2,600. So I can do that type of things. I'll see everything that starts with A. That's to give you an idea of the performances of the engine. This is not SSD. I know that some sessions insisted on SSD, but it's not just 7,200 tools. It is quite a slow disk that I use for the presentations. To show you the performances, I'll show you something more interesting. It is actually quite difficult with the space constraint on the screen. So I put a simple event here, the bias hub, for example. Every time you type something here, you do research. You take it in your source, that is in employee. So I do exactly the same thing as before. I do a request, a query with the name. And here as a parameter, I take the value. I could have used this, but I like to do it like this. So I'm going to call it text field 1. Here I use, we copied on jQuery. Here I put $, to have access to all the widgets in the framework. In order to avoid to have the widget by taking it from the widget list, when you're in the, I can ask wa.widget to have all the widgets. Here I have my data grid, so I can have my data grid accessible. So this syntax here equals $, data grid 1. It's just a shortcut. And then on my widget, And here I ask for the current value. And I add the joker character. By writing this code, and I'll run it, I refresh my page. I start typing something, LAR, for example, and every time, if I look at the network, so every time I have to put it back to 0. With each character, you have a query sent to the server. So if I type in LAA, 3 queries were sent to the server in REST. The first one, the rest is REST. The resource we're interested in is the data class employee. We want to limit that to the 40 first ones. So we want to limit it to the 40 first ones. I send my filter, the parameters that have passed for the query, and I want to do a collection on the server in order to hide this collection and save time with the server. So here the query has arrived, but I was in LAR. So once this collection is created in the server, it can be accessed with the identifier, the ID. That's the technical behind the magic. Now, if I move and I go to other pages, another query appears with this time in the parameters a copy of the other parameters if you lose the connection in the server. And the URL, the ID here, it's the ID of the collection on the server. So once I do the query, regardless of the complexity, I don't have to do it again in the pages. Every time I take the 40 following ones, or the 41st ones, if I use the scroll bar, I navigate in the collection that was created in the server, that was created very quickly with our own technology that is not based on another technology. You know, here we work directly on the data, and it's it's very fast actually, far faster, much faster. So here it is the same collection, and when you look at the past parameters, you see that it was asked to be placed at the 719th one. And so if I go down, there's no other queries because I'm part of the group of the 60s that was sent. So the system hides the data automatically, more or less. So that's one thing. But you can also have more interesting requests. Here, I like to see, for example, the corresponding company. It is very simple. I modify my grid here, and I add in the grid I like to see the company it works for, and I like to say that it is the employer. And in the employer, what I'm interested in is only the name. By doing that, I record, and now I add the company for this employee. And now I can do more sophisticated queries, the equivalent of a joint in SQL. Select with jointing in between two tables. I like to be able to get all the employees, which company, so here's going to carry out a research, and I do this query. Is found 18,000 out of 1 million, just to give you an idea of the speed of the volumetry of the volume, the way it is processed. If I am on the server side to see the query, I have actually a far simple. I can do exactly the same thing on the server side. So I can do DS employee. So here I create a collection, and once I have this collection, I can ask for the length. The collections are a way to be manipulated, in order to be manipulated or handled as an array on the here. Every time you do the request here, I can also see the way the request was executed. So I can ask to have the query plan. So here you can see so it only enlarged the top part. So it shows that it joined the company and the employee. Everything that starts with anim, actually. The driver on the server side is really very sophisticated. It enables you to do any type of query, including queries that are not simple to express in SQL usually or in 4D language. In this case, for example, I have a manager in my model. If I want to get all the people that work for a manager, all the people that have a wage that is above 70,000 euros, for example. So it's above 17,000 euros here. But at the same time, I would like these employees to be found to have a wage and below 60,000 euros, for example. So this is what I do. Here, There's 120,000 out of a million. If I look at the way it did the query, it is very simple. It realized that it wanted to have a recursive joining, so it created the equivalent of an alias in SQL in the employees that it calls employee 1, and in the employees is looking for the manager. Employee 1 is the manager's, well, it's all those who have a wage that is below 70,000 euros. It uses it to filter the jointing, and that's how you get the result. So you can express very complex queries in a very simple manner, and the execution of the query is very dynamic. There is no construction as in other systems, such as mapping, relational object, construction in SQL of the queries. Everything is done dynamically. That is to say, the engine supports that type of queries. Okay, this idea of data source is actually quite important. When I look at the data, well, that's what we have decided. We decided to name the first source that works with data class with this data class. So, but frequently, on the same page, I want to represent several collections of the same data class for different reasons. So you just have to create different sources on the same data class. So I reduced the grid in order to have more room. I like to see employees also. So I can duplicate this source and call it, for example, employer. Now, with the user, I have two sources. One that is linked to this one. So if I modify something here, well, I changed something, but I did not change anything there. Now, if I look at the source here, and then I do a query on it. It's not name, it's last name. I just wanted to make sure that everyone was following. So the sources are really independent. So each time here, I work with quite a high volume. It's not only 2 or 3 entities. You can see the answering time. So you can have a complete application that can be used. What is important to understand is that each query is sent to the server in a separated thread. So the multi-threading is automatically managed, and to have a vertical scaling, that is really quite a major one. We have carried out tests in a machine that was lent to us with 8 processors with 6 hearts each. So we were able to do loading tests with SSD. It's much better. There's no miracle here. Here we have, if you do not have SSD disks, you're going to waste time in displacing the reading. So it's going to lower the performances. While with the SSD, you can have up to between 20 up to 40,000 operations per second, which is plenty with high volume, with large volume. So Wakanda is really able to manage major volumes of data and to create volume interface. I'm not a very good designer, so my interfaces are not very beautiful, but you have people that make some much nicer interfaces. Now, I define my model here. There's no much difference here. With a relational database, I can have the tables, I do my queries differently, but there isn't much difference apart from that. Where we go much further is that a data class is not a table. It is actually a collection of entities that are objects and which have properties that use the power of JavaScript. In the presentations that were made today by David Robbins, where he explained that one of the major asset of the JavaScript is to have functions. So it's the same rationale on the server side. So you can apply functions in a lot of places in the server, but you can add simple things on more complex ones. The birth date, for example. It is an attribute, but very often, just as a human being, I find it easier to work on the age rather than to work on the birth date. And when I define my business line rules, it's the same. For example, in a country, for example, you say alcohol is prohibited to people younger than 21. So you're based on age. But if you get the idea of the people, you look at the birth date and you work with this. But usually you work with age. So I will have to have a field, a calculated field based on the birth date, but I don't want any penalties when processing the data. In a lot of systems, if I have a calculated field, which is the age in relation to the today's date and the birth date, when I do a query with that, for each entity, you recalculate the age, and then I have a sequential query that is going to execute a JavaScript query, which is not optimal. Now, we have a way to put the right functions at the right place to say, okay, when you have a query on age, for example, you know that it's not the age I want, but the birth date. So I have a way to tell Wakanda, replace in a query the age by the birth date, and do it that way. So I'll show it to you how it is done. And in the model for each class, I have defined JavaScript codes. So for the employees,
I'm going to reduce a little bit so we can see the specific point more clearly. So actually, I defined the attribute. Here it is. The age attribute is calculated, and it should have a digital value, a long entity. What have I done? Each time that we wanted, in one way or the other, to have access to age, perhaps it was for debugger purposes or for the retrieving of a REST query, or if it's because in a date attribute array, when I need to have age, it goes through this onGet function, which is a function which will calculate age based on the birth date. What I've done, in fact, I have this calculation based on the birth date, and they use the compute age function. Now, of course, this is a delegation system. I say I delegate the onGet, I delegate the onQuery to this function. If I hadn't put the onQuery, it would have functioned in any case. But it was in, we haven't delegated the onQuery, so that's why I'm going to use the onGet, and I'm going to use a sequential query. So I can have these kinds of the old standard way of doing things. If we don't have a lot of data, we don't have to do really sophisticated systems, but the simple onGet is enough in that case, and then it will be applied to each call for each entity. Now, when I want to do something a little bit more sophisticated, when I have a larger volume of data, for example, in that case, then the onQuery will receive the operator of comparison, compare operator, and the value to be compared. So when, for example, if I query age equals 26, I will see in the compare operator a string that will be equal. For those of you who use some JavaScript, we use this. We're going to have equal in the future because people say that that's an insinuation related to that, so it will be equal. So now I have the compare operator here in the string, and I have the compare value, which will be 26. I can return a string that will be a subquery that will replace my query where I have age plus 26, because I want it that way. So here I have defined in my utilitarian unit, here I have this function. I have an m-space date tool, and here I define different functions. For example, compute age. And there's a mathematical formula to calculate the number of seconds, etc., between the dates, and of course it divides, and then you have a number of years, and then you have the date tool build query. What does it do? It sees if the value to compare is null. If it is null, then null is not 0. It means we don't know. Null means we don't know. Now, if we don't know if it's null, then we don't know the date of birth. So the attribute name will be the date, will be the birth date, because that was my parameter. And there's equal to the attribute date birth because it is null. And so if you have the lower limit and the upper limit that is defined, so if I have 26, for example, which is not my case, unfortunately, but if I were 26 years of age, then I would have the date birth, which would be between two dates. My date of birth would be between two dates that are separated by 1 year. So I calculate these two limits, and then I replace my query by superior to the lower limit in the quality of equality. In the quality of higher, more than, it's less than the lower limit. So this is what I do, basically. Now, for the use, is what we want to look at now. I'm going to do a query. I want to find, for example, all of the staff whose age is equal to 27. If I look at the query plan, it's already done it. So it's a field calculated with 1 million different records, and it replaced it by the employee birth date between this information here. In my code, I put less than a certain thing and higher, more than another certain thing, but the search engine goes further. When I have given the string that I give it as a replacement query, then once again, it goes through the search engine to see if it can be optimized to it can be optimized between a range between two values, which is quicker when you have a certain diagram rather than doing separate queries. It's very much optimized to do these kinds of things. Now, if I want to find all of those who have an age equal to 27 and to work for a manager whose age, so manager dot age, so manager is a field and attribute of a relationship, of a relation in my entity. This relation attribute, it points to another attribute, which is an employee. This employee has an age as well. I can have a field calculated on the manager. And the search engine will manage to apply the right format at the right place. So I will ask the manager's age equals to 32, for example. If I look at the query plan, then it's more sophisticated. And then he did this research index based on the birth date, again, between, as we said, here we have examples 27, and it makes the joint between itself and the joins on the table for the employees, and it also does the query for employee 1 between this birth date and this birth date to correspond to 32. And all of this with reasonable time. So if we look at the files, so look at 445, for example, files. So here we have very powerful possibilities in the way we can handle data. The search engine will go further than simple queries. When I define my model, there's something that interests me, which is to be sure that, in fact, the first names, last names are always formatted with the first. The first one should be in capital letters, and then the rest in lowercase. So this is how I define it in my model. Now here I have a model where I've constructed it by programming. I can also construct the model by the editors, by adding these different arrays, but I've decided to construct the model through programming. This has advantages and disadvantages. Well, it's something that's more difficult at the beginning. The advantage is that we have total control of what we do. We choose to break down our JavaScript files that corresponds to the model where we desire them. We have the hierarchy that we want. We can put them in the different file sets that we want. We have a lot of control over this. In this given case, if I look for example, my employees, I have, you see employee.js. I decided to create this class, which is employee, with the attributes. You can see the ID, first name, last name, salary, and also for the first name and last name, I would like now to have an event which shows that regardless of the reason and the way that I modify my attribute, I want to be called so that I can format it in the way I want. So for example, I have this add event listener. Okay, on the server we have these events that are different places, lots of places. And we can delegate persons who will be listening to these events to handle the event. I can put this on the onset. The onset, once I have modified the value, then it will be called. Now on the onset, I will call the function set to capitalize. I do this for the first name and for the last name. This function is defined here. It is quite simple. Set to capitalize receives a parameter, an attribute, with which the event will be executed. And here, if this is the object in which we execute the event. This is the attribute within my object, and this is the object. The object is the entity. In this is an employee in this specific example. I look and see if my employee has an attribute which is not null. If we have a null value, we cannot modify it. But if it's not null, then in that case it's a string, because in this case I know it is a string. So I use the capitalize function, which is part of the functions defined on the Wakanday server, to have a capital letter being inserted. For the user preferences like this, I'm going to create an employee. As you can see, as I'm doing it, new ds.employee. And I'm going to create this employee. I'm going to use, to do this, one of the syntax possible to create entities. The data class under the constructor. If you have seen David Robbins' course, you can use JavaScript constructors to make one's own, or you can also for the logics that are defined by the model. So I'm going to I'm going to put last name. So let's say Laurent, a little French name, and the first name, Jean. Before saving my entity, if I'm not going to save, I'm just going to create it. It's in the memory, all right? Yes. If I execute this, and then if I want to see my entity, here you can see already the event listeners were called. So this way we have a control. This is a simple example, but we of course can do much more sophisticated things at different places, in the set, in the get. If I continue going on here, all of this of course is visible graphically. If I want, for example, I can click here on my attribute, and I can see in the events that I have onset. So dynamically, the code refreshes the graphical model to present to you what enables you to see where you're at when you decide to actually input this data. Now, for a class, it goes further. We can define one's own method. What's interesting, for example, for my employees, I would like to construct, in my example, I would like to have, for example, this kind of a game example. So I have 1 million employees. I have a special dictionary of names that I found on the internet, for example. So I have a large code that does that. Now the code is all in here. And you see it's quite voluminous. I don't want to enter it. So this will, you see, this is how I've done it. This code, in fact, I don't always want it to be present in my context. It's large. It was JavaScript. Once we've evaluated a function, it's there. If we don't destroy it, then it's there. But it's too bad, though, because I'm not going to use this code. So in the present case, I'm using it from this page for my building my data. Once I have clicked on the button here, this is maybe not yet perfect in design, but I've made a little bit of effort. Here I have an event, and on this event, I call the build data, as you can see, the client side. Now, the function that I've defined in my model, I've asked that it would be public, and so it is public, then it's accessible for the client side. And also, public function can be restricted with different authorization for execution for a given group, so that it can it's restricted to being executed by a certain group. So I have lots of commands for that. So I call this build data. If it's a success, then I stop the progression. If there's an error, then I also stop the listening. And then pass a value in the parameter that I have actually gotten from my input text. This function, it is large. I don't want it always to be present in my model. I have a simple way to do things. Now, in this case, in my model, here, as you can see, I was saying I wanted to add the method build data, which will be a special data class method. And this is a function which has a parameter, the number of companies to be created. And well, what do? The body of the function is empty, or almost. And I include the JavaScript code that you have seen earlier, the build data. And I execute, this time, the build data, which is in the JavaScript body. What's interesting about doing that is that if I'm not here, this add method, this defines this function. So it has, you see, just takes up 2 lines. Now, the include will only be executed if you have the build data execution, not during the creation of the model. So I, in this way, can have a very large model with 100 different classes that don't take up much room in the memory. And you see how I can do this. Now, in this case, I could have merged different functions in the same JavaScript file, but I could say break it down into different functional elements that are called at the right time. This is just a part of the things I wanted to show you, but I'm running out of time. This person is speaking off mic, but I understand there will be a Q&A session at the end of the day.